Hello everyone, and today we're going to talk about different types of forces. So in our previous lessons, we have looked at what forces are. We have also looked at Newton's first and second laws. And in Newton's second law, it says the formula F equals to ma. In our lesson 1, lesson 2, we looked at how we could use Newton's second law formula F equals ma to work out either the force or the acceleration. So today, let's talk about the other types of forces. Now, there are several different examples of forces you should be familiar with. When you do a question, you need to firstly be able to identify all forces acting on an object. Secondly, be able to draw a force diagram. So if you have a look at this picture on the screen, which is a car, so let's think in real life, what force do we have acting on the car? So for example, if the car starts from rest and is to accelerate, there must be a driving force acting on the car to help the car accelerate. So if the car drives towards the right-hand side, there must be a friction acting on the car as well. And of course, we could also have air resistance. Now, let's assume that this car starts to decelerate. That means we must have a braking force to help the car decelerate. So those could be the potential forces acting on the car in different situations. Now, in mechanics, if it mentions that there is a smooth surface, that means the friction force between the object and the surface can be ignored. So you have to be really careful with the question. Okay, so let's have a look at an example. So in this example, part A car moves under the action of a driving force of 1,740 Newton. The total resistance to motion equals to 600 Newton. Given that the acceleration of the car is 1.2 meter per second squared, find its mass. So as I mentioned before, you need to be able to identify all the forces acting on the car and also draw a diagram. So why don't we start by drawing a diagram labeled with all the forces labeled on the car. So part A. Okay, so I'm trying to get to this page. Okay, so part A. There we go. Okay, so let's say this block represents the car. Okay, so we have a driving force of 1,740 Newton. And then let's say this force is acting towards the right-hand side. So if the car moving towards the right-hand side, that means the resistance force, 600 Newton, must be acting in the opposite direction. 600 Newton. Okay, so that means we can see overall the resultant force or the net force acting on this object would be 1,740 at a negative 600. So let's write down our Newton's second law. F equals ma. So 1,740 plus negative 600. And that equals to the mass of the car, which we don't know, let's use m, times by the acceleration, which is 1.2. Okay, so here on the left-hand side, that will just equal to 1,740 minus 600 equals to 1.2 m. Okay, so then over here, we will have 1,140 equals to 1.2 m. By using a calculator, we can very quickly work out the mass m equals to 950 kilograms. That's the answer for part A. Okay, so let's have a look at part B. So for part B, it says the car starts to brake and decelerate at 2.5 meter per second squared, assuming that the total resistance force remains the same. Find the magnitude of the braking force. All right, so again, let's start by drawing a diagram with all the forces labeling on the diagram. So one thing we have to be careful is the car starts to brake and decelerate. But what is the motion of the car? The car was still moving towards the right-hand side. So if the car is still traveling towards the right-hand side, then the resistance force was still acting towards the left-hand side. So that means the 600 Newton will still remain on the left side. But in part B, we have a different force acting on the car, which is the braking force. So the braking force is trying to stop the car moving forward. So if I want to stop the car moving towards the right-hand side, that means my braking force must be acting towards the opposite direction, which is the left side. So that's my braking force. Okay, so then let's use F equals ma. So now what is our resultant force? Well, as we said, both the braking force and the 600 Newton acting in the opposite direction of motion, so both of them will have to be negative. So we would have, let's say braking force is B. So have minus B plus a negative 600, so minus 600 equals to 1.2. No, sorry, that's not 1.2, isn't it? Apologize. Let's get rid of this number. And the mass we have worked out before is actually 950. And then times by, now what is the acceleration? Well, here in the question it says it decelerates. So if it decelerates, that means it would be negative 2.5. Okay, so by rearranging the formula, you put in a calculator and work out that the braking force B equals to 1,775 Newton. That's our final answer. Right, let's have a look at another example. Okay, so what do we have here? In this question, says a small toy of mass 230 grams moves along the floor with an initial speed of 8 meters per second. Part A, the contact between the toy and the floor is modeled as smooth. So do you remember what we talked before at the beginning of the lesson? If the floor is modeled as smooth, that means there is no friction. Okay, we need to predict the time it will take the toy to travel 6 meters. Right, so for part A, it's actually fairly straightforward. So we are looking for the time. We know the distance is 6 and we've been given the initial speed. Okay, so assuming if there is no friction, we don't need to worry about the force acting horizontally. So that means we can just use speed equals distance divided by time, or another word, time equals to distance divided by speed. So that would be 6 divided by 8. And we will get 0.75 seconds for part A. Right, part B. The toy actually takes 0.82 seconds to travel 6 meters. Find the magnitude of the friction force. Okay, so let's think, what do we have? Well, if there is a frictional force, that means there's a force acting on the object, so we must have an acceleration. So what we have here is that we could draw a diagram. Okay, so let's say this block represents a small toy. Okay, and the toy is again traveling towards the right-hand side, which means the friction will have to act towards the left-hand side. And let's use little f to represent the frictional force. Right, so that's the only force acting horizontally on the object. So let's start to think. Now, if I want to work out the force, the only formula we know is F equals to ma. So to be able to work out the frictional force, I must know the acceleration. So how do we work out the acceleration? Well, that would link with the previous chapter, which is on the Suva equation. So let's write down our S, U, V, A, and T. So do we know the S? Yes, it says clearly in the question, it travels 6 meters. Do I know the initial speed? Let's have a look in the question. And yes, the initial speed is 8 meters per second. Do I know the final velocity after 0.82 seconds? No. So we can cross this one out. And acceleration is something we're looking for. So put a question mark next to it. And the time is 0.82. So let's think, which Suva formula do we want to work out the acceleration, and it should not involve the velocity. So hopefully you have realized the Suva equation we need is S equals to ut plus half kt squared. So let's substitute in the numbers. So we have S 6, U is 8, and time is 0.82 plus half A times by 0.82 squared. Now, because I only have limited amount of space left here, you could put this equation into a calculator and work out the A. So you should really get your acceleration will be minus 1.67 meter per second squared. So why the acceleration is negative? Well, if you think that there is a frictional force acting on the toy, and that's the only force acting that means the toy would have to slow down, which means it's decelerating. Hence, we have a negative answer for acceleration. Great, so now we know the acceleration. We could put into F equals ma to work out the frictional force. So let's write down over here. So F equals ma. And the only force we know is the frictional force, so little f. And that equals to m, which is 230 grams. Now be really careful with this number. The unit is in gram. However, when we use our acceleration meter per second square and force, it should be in terms of kilogram. So we need to change this number to 0.23 kilogram before using it. So now let's substitute in. So we have 0.23 times by acceleration, which is negative 1.67. and our frictional force F come out to be negative 0.383. Okay, hopefully you can read my handwriting. Unfortunately, it's not very good today. Right, so now the reason why the frictional force is negative is because we have assumed at the beginning that the box is moving towards the right hand side. So when you answer the question at the end, you should say that the frictional force, the magnitude of this frictional force is 0.383 as your final answer. Okay, so shall we have a look at the next example? So what do we have here? In this question, it says a box of mass 24 kg moves on a rough horizontal floor under the action of a constant horizontal force. And we can see here that force is given in vector form. Find in vector form the frictional force acting on the box when its acceleration is 0.7 I minus 1.1 J meter per second squared. Okay, so let's think. What do we have here? So again, why don't we start by drawing a simple diagram with all the forces labeled in horizontal direction. So it says it's moving under a constant horizontal force, and it has a rough floor, which means there will be a friction. So again, let's assume that my box is moving towards the right-hand side. So the force used to move the box will be 16I plus 11J. And the frictional force will have to act in opposite direction. And again, let's use little f for the frictional force. Right, so let's check, do we have the mass in kilograms? Yes, so we can use that straight away, and also we can give the acceleration. Perfect, so let's put that into our Newton's second law, F equals to ma. So let's write this down, F equals ma. So what is the resultant force? So the resultant force will equals to 16I plus 11J. So why don't we write it in the column form? It's just slightly easier for us to visualize what's going on. So 1611. Now we can either write plus or take away, it's up to you. But let's say we're going to put plus little f for frictional force. And that equals to m, which is 24 kilograms, so 24 times by the acceleration. Again, in column vector form, that would just be 0.7 and negative 1.1. Okay, so now what we would get is that we could work out what is 24 times by 0.7 and negative 1.1. So that would be 1611 plus f equals to 16.8 and negative 26.4. So that means f will equals to 16.8 minus 26.4, take away 1611. So our frictional force will now end up to be 0.8 and minus 37.4. So if you want to write in INJ form, little f will now equals to 0.8I minus 37.4 J. Okay, so let's move on. Right, Now, when we are moving an object, especially the case when we try to pull or push a box, there's certain things we have to consider. So, for example, if you are pulling a box using a rope, you are not acting on the box directly. You're pulling on the rope, and the rope pulls the box. The force exerted by the rope on the box is called tension, and is directed away from the box, so that means it'll be towards you when you're pulling the box. However, if you use a stick or rod or a tow bar instead of a rope, then you could push the box as well as pull. The pushing force provided by the tow bar is called thrust, and it is directed towards the box. So here are the two diagrams to demonstrate the direction tension. So tension means you're pulling the box towards you, so the direction will be towards you. But if we have a rod or tow bar, then you're pushing the box, and that means the force, which is the thrust, will go towards the box. So this is a very important, because we need to know the direction of force in order to think about the sign in front of force in the formula F equals ma. So it might be easier if we actually look at an example. So let's have a look at the next example. Okay, so here in this example, we have a boy is using a light horizontal stick to pull a toy box of mass 3.2 kilogram across rough carpet. The tension in the stick is 18 Newton and the friction force is 7 Newton. Part A, find the acceleration of the box and the time it takes for it to accelerate from rest to 2.1 meter per second. Okay, so again, when I start to go through this kind of question, I would always start by drawing a diagram. So let's do that. Part A. So let's think what the diagram will look like. So again, let's use a little box to represent the situation. So in this case, the toolbox. So what do we have? Well, here it says the boy is using a light horizontal stick to pull the toolbox. So here it says the tension in the stick is 18 Newton. So assume that our box is moving toward the right-hand side. So that's our positive direction. If we're pulling the stick, that means we have a tension. And in this case, it's 18 Newton. Now, however, because it's being pulled across a rough carpet, that means we have friction force acting in the opposite direction of motion. So if the box moves toward the right-hand side, friction force will have to act towards the left-hand side. So that is 7 Newton. So then we could use F equals ma, write down the resultant force, so that would be 18 plus negative 7, and that equals to the mass, which is 3.2, times by the acceleration. So we can very easily work out the acceleration, what equals 18 take with 7, which is 11, and then divided by 3.2. So that will come out to be 3.44 meter per second squared. Okay, so now I know the acceleration. In the question, it then asks you to work out the time it takes for it to accelerate from rest to 2.1 meter per second. So we now need to consider suva. Let's write down our S, U, V, A, T. Now, do I know S? Unfortunately, not in this case. Excuse me. Do we know the initial velocity or speed? Yes, we start from rest, so that's 0. Do I know my final velocity? Yes, we come up to 2.1 meter per second. And we have just to work out the acceleration is 3.44. And the time is something we're looking for, so let's put a question mark. So you can see I'm looking for a silver formula which does not involve the S. So the one I'm going to use will have to be V equals to U plus AT. So substitute the number in, we have 2.1 equals to 0 plus 3.44 T. So T will now come out to be 0.611 second. Okay, right, that's part A done. So let's think about part B. What do we have here? Part B, assuming that the friction force remains the same, which will still be 7 Newton, what tension is required for the box to maintain a constant speed of 2.1 meters per second? So what does that mean by maintaining a speed? Well, we maintain a speed, that means there's no acceleration. So which means acceleration A equal to 0. So if you think the formula F equals to ma, if A becomes 0, that means F has to be 0. How come the F is 0? So that means the resultant force for the net force has come out to be 0. So if we have a 7 Newton acting towards the left side, for the overall force to be 0, that means we must have a 7 Newton pulling towards the right-hand side. Hence, the answer for part B, what tension is required, we would say the tension will have to equal to 7 Newton. So the answer is 7 Newton for part B. Okay, so far so good. Let's have a look at the last part. Now, next bit, the boy now makes the box slow down by applying a different constant force through the stick, and the box comes to rest after traveling 0.8 meters. The friction force is still the same. Part C, find the magnitude. Sorry, I have to stop for a bit. My cat's coming to drink my tea. Go away. Okay, I think he has successfully been blocked from my tea. Sorry, part C. Find the magnitude of the force in the stick and say whether it is tension or thrust. Right, so if the box starts to slow down, that means we will have a different acceleration and hopefully it should come out to be negative. So let me just quickly clear the screen. Okay, so let's start it again for part C. Okay, so as I said before, we need to look for the new acceleration. So we have to think about silver again. So let's use S, U, V, A, T. Now, do I know S, how far it traveled? Well, let's have a look at what it says. It traveled 0.8 meters. So S is 0.8. I don't know A, that's what I'm looking for. So let's put a question mark there. And do I know V? Well, in the question, it says the box come to rest. So that's our final velocity. Actually, sorry, this is not A, isn't it? This is U, what I'm talking about, because I write it things like A. Sorry, so I don't really know, or do I know U? Let's have a look at the question. Yes, we do know U. U is actually 2.1, so let's cross this out. Okay, because in the previous question said the speed is actually 2.1, now become rest, so 0. Great. So this is something we're looking for. So that's the question mark. And do I know T? No. So let's cross this out. So when you think about silver equation, does not involve T. So that means the one I have to use will have to be V squared equals to U squared plus 2AS. Okay, so let's substitute our number in. So G is 0, and that equals 2. So 0 squared equals to 2.1 squared plus 2A times by S, which is 0.8. Okay, so by rearranging the formula and put the number into a calculator, you should be able to work out that the acceleration A equals to negative 2. Something's not quite right with my pen. Cross this out. So it's a negative 2.76. Okay, so that's for a negative 2.76. Now I know the acceleration. I could put into F equals ma to work out the force in the stick. So let's write this down. F equals to ma. I'm not quite sure what's happening to my pen at the moment. Let's move this down a bit. Okay, so as we said, we have another force acting on it. Let's say it's T, either stands for tension or thrust. Okay, what other forces acting on it? Well, it has to be the frictional force, which we already know is 7 Newton, and it has to be in opposite direction to motion, so it's always negative. So we have T plus, or take away, you could say, 7 equals 2 m, which is 3.2, times by the acceleration, we just work it out, so minus 2.76. Okay, so then by putting the calculator, we should be able to work out T equals to negative 1.82 Newton. So assuming that the block is moving towards the right-hand side, and the force we worked out is actually negative 1.82, which means it's not going to the right side and it has going towards the left-hand side. So that means it's a force acting onto the object in this direction towards the left-hand side. So that means there must be a thrust instead of tension, because if it's tension, that has to be pulled towards the same direction as motion, which means towards the right hand side, but thrust would go in opposite, which is the left hand side. Okay, I give up on writing. You should be able to understand this. Right. Okay, so now hopefully you now have a good understanding of different types of forces and how they would act on this object. And we have looked at some examples of how we can link the super equations in the question to work out the acceleration, and then use acceleration to work out the missing force. Now, in those examples we talked about, you have to be careful with assumptions you make. So, and also those, they are the frequently asked questions at the end of the exam question as well. So let's think about this. Should we include the mass of the rope of the rod? Well, in practice, its mass is almost always a lot smaller than the mass of the object you are trying to move, so you can ignore it. But when we do the question, we need to say that the rope is light, and it does not stretch, and it is inextensible. So those three things are quite important assumptions, and you need to remember them, as it could be asked in the exam. Okay. Right, so let's move on. Now, here we go. So I would like you to try some exercise from exercise 21. So here are the first 4 questions. If you do not have the book, please pause the screen and you can try the question first before you look at the answer at the end of this video. Here comes questions 5 to question 8. And here we have question 9 to question 11. And here we have question 12 and question 13. And at the end, here we have the answer to those exercises you have done. I will also email out the lesson notes. So if you can't read the text on the screen very well, please download the PDF version of the lesson notes to use it go along with the video. Okay, thank you for listening. Bye.